In this video, we will discuss centripetal acceleration, its magnitude, and direction. So let's start our topic. Let's try to understand centripetal acceleration. When does it come into picture? What is its magnitude and what is its direction? Now, the term centripetal acceleration means that acceleration which is directed towards center. It is also called center seeking acceleration. This comes into picture when we have uniform circular motion. Now, what is this uniform circular motion? Uniform circular motion means when a body moves in a circular path in such a manner that its velocity is constant in magnitude at each and every point, then it's called uniform circular motion. Now, for example, this is a body shown in blue color. It's moving in a circle with center at O, like this. Now, suppose at this point its velocity is v1. At any other point, velocity is v2. At any other point, its velocity is v3. Now, whether it is v1 or v2 or v3, they are different in direction but same in magnitude. v1 is equal to v2 is equal to v3 in magnitude, means mod of v1, v2, v3 are equal, and that is equal to v, say. At every point on this circle, the velocity is same in magnitude. Only thing is direction keeps on changing. At every point, the direction is changing. This is called uniform circular motion. Now, in this scenario, there is bound to be an acceleration, and the reason is that velocity is changing at every point. Suppose the body is at this point, and say after very small gap of time, extremely small gap of time, the body moves towards right at this position. Now again the velocity has changed in direction. So some may ask that since velocity is constant in magnitude, how come there is an acceleration? Velocity is a vector quantity. The vector can change in magnitude, it can change in direction, it can change in magnitude as well as direction. In all the three cases, there is a change in vector. So, velocity is changing, and whenever there is a change in velocity, there is an acceleration. So, at every point, there is an acceleration which is directed towards center. At this point, or at this point, or at this point. At every point, there is an acceleration which is directed towards center, and it is same in magnitude. This acceleration is called centripetal acceleration. Hope you are clear till this. Now let's find magnitude of centripetal acceleration and how it is directed towards center. Now we'll find the magnitude of centripetal acceleration first, and then we'll find the direction. Let the body move in this circle with radius r. Let it be at p1. Let the velocity be v1. And after a small gap of time, let it be at p2 with velocity v2. This is also r. Now let the radius sweep a small angle delta theta. Delta theta is very small. And let the r, p1 and p2 be delta s. Now delta theta and delta s are very small. p1 and p2 are very close. We have just drawn it like this. to explain it to you. Now let us extend V2 backwards and make a dotted line at V1 also. Now can anybody of you guess what is this angle? Suppose this is alpha. Just pause the video and guess. I think most of you must have guessed. Alpha is also delta theta. But again, I'll explain you how. This angle is 90 degree because angle between radius and tangent. So this angle is also 90 degree. Suppose this angle is beta. Now this is a quadrilateral and sum of all angles of quadrilateral is 360. Two are already 90 and 90. Add up to 180. That means delta theta plus beta is equal to 180. And now alpha plus beta also is 180. So delta theta is equal to alpha. That means this angle is delta theta. Now let us draw vectors v1 and v2 separately. v1 and v2. And the angle between them is delta theta. Now can you guess what is this vector in blue color? This is v2 minus v1. That is delta v. If you have studied vectors, you will understand that that is delta v, that is change in velocity. Say this is ABC, this is a triangle, and this is a sector, both shown in shaded blue color. Now, if delta theta tends to 0, sector O, P1, P2 can be considered as triangle. Because if delta theta is very small, P1, P2 is very small and can be considered as a straight line. Now, in that case, triangles A, B, C and O, P1, P2 are similar. Why are they similar? Because this angle is delta theta, this is delta theta. Here both sides are equal r. Here also V1 and V2 are equal in magnitude, say V. So now the sides of similar triangles are in same ratio. That means P1, P2 upon BC is equal to OP1 upon AB. That means now P1, P2 is delta S, BC is delta V, OP1 is R, and AB is V. So that means delta V is equal to V upon R into delta S. Now divide by delta T on both sides. Now when delta theta tends to 0, then delta T will also tend to 0 because if P1 and P2 are very close. So put the limit delta T tends to 0. Delta limit delta T tends to 0. Now delta V upon delta T is the instantaneous acceleration A, which is equal to V upon R, and delta S upon delta T is the instantaneous velocity V. So acceleration is equal to V square upon R. Now V is equal to R omega, R square omega square upon R, which is equal to omega square R. So acceleration is equal to V square upon R, which is equal to omega square R. This is the magnitude of centripetal acceleration. Now we'll see how the direction of centripetal acceleration points towards center. Just draw the same figure. Now we have to find the acceleration. How do we find the acceleration? Acceleration is change in velocity. So what is change in velocity? V2 minus V1, and that is equal to delta V. So just subtract V1 vectorially from V2. So just reverse the direction of V1 and add to V2. So this blue arrow is V2 minus V1, that is delta V. Now this is the direction of change in velocity, and this should be the direction of acceleration. And we were telling that it is pointing towards center, but here it is pointing in this direction, not towards center. So what is wrong here? Actually, it is instantaneous acceleration. That means delta theta has to be very small and it has to become nearly zero. That means delta theta will be tending to zero. So what do we do to find the direction of centripetal acceleration? We will gradually reduce delta theta, and that means we'll bring P1 and P2 closer. Now this is P1 and this is P2. Now just bring them closer. Now you just see, in this case, delta V was in this direction. Now the direction of delta V is this. That means it is rotating towards O. Bring them again more close. Again more close. So you can see slowly the direction of delta V is rotating. The vector delta V is rotating towards O. Now when delta theta tends to 0, that means delta t also tends to 0, then only it will be instantaneous acceleration. In that case, delta V will point towards center. It's not possible to draw. So that means instantaneous acceleration, which we are calling centripetal acceleration, that will be equal to delta V upon delta t, limit delta t tending to 0, and its magnitude we already told, V square upon R. So hence we can see that acceleration is equal to delta V upon delta t, limit delta t tending to 0. Its value is V square upon R. Hope you have understood how the direction of centripetal acceleration is towards center. Now, till now we discussed uniform circular motion. Now, in case of non-uniform circular motion, what do we mean by non-uniform circular motion? When the velocity changes in magnitude also, then acceleration has two components. One component point towards center and one component is in direction of tangent. The direction of acceleration pointing towards center will be called centripetal acceleration, and the other will be tangential acceleration. Just see how. Suppose this body is moving in a circle like this. It has a velocity v. At this point, it has a velocity v. So centripetal acceleration will be pointing towards center, which we are denoting by AC, and there will be tangential acceleration also in this direction, which is called AT. Now, centripetal acceleration will be equal to V square upon R, because velocity at this point is V, and tangential acceleration is equal to dV upon dt. So the resultant acceleration is the resultant of these two vectors, which is AR AR is equal to under root AC square plus AT square. Why I have taken like this? Because the angle between AC and AT is 90 degree. So you can see in this case, the resultant acceleration is not pointing towards center. It points it in other direction, which again depends upon uh, the value of AT. I hope this is also clear to you. That's all in this video. Hope you found this interesting. Thanks for watching this.